Okay, so now this is all the caches loaded. Let's have a look at from the camera view, something like this. I guess if we go to our last frame, no, this is not our last frame. 1250 is our last frame. Sorry, that should now break. It did it, or is gonna load the last frame. I'm not sure. It's doing something, so I don't want to break it. Okay, yeah, it default back to the first frame. So let's go 1250 as our last frame range here, and then this should now go clamp itself to 1250. Letting it load. So the next thing we're going to implement is frustum culling. Because from the right input we got all the points coming in, so we should be able to do some nice fancy stuff here to remove what we don't want to load if it's outside the camera view. So all that stuff we don't need, right? And we probably could have done a little bit better job by saying here, if you fell under a certain distance, go static. So that could have probably speed up our simulations. But now let's just implement the frustum. So let's select our input. First block begin. Create another import. Just select this guy only. Let's drag this guy here. I'm gonna take this a bit further down, and also going to limit it to single pass, so my results are a bit faster. All right, so where's the camera? Let's see, the camera is here. So according to this logic, we shouldn't be seeing anything but this part and this part after the frustum is loading. So let's create a volume. Okay, I'm going to create a volume named density, and it's defaulted to 1, and it's based on camera. So we're working for shot 1, let's say. So obviously this needs to be replaced. 0 to 1000, the camera itself needs to be replaced based on what camera you're rendering. So this guy is going to be named in camera, and it's going to be fetching the input. Okay, now the next thing we're going to do is that we're going to create a clip swap. So we want to now start doing some cleanup on these points, but not on this side, but on this side. So I don't want anything below 50 meters, minus 50 meters, right? Because we had some chunks that were really going deep. Let's see if they're here also. Yes, so we're removing first those guys. Then I'm going to put an attribute wrangle here. There's some space here. Let's bring this guy up. First input are the points. Second input is the volume. Let's call this frustum culling. So this method is using volume sample. I'll just copy paste the volume, the code, and then I'm going to explain what it does. So we're creating an integer named in, and we're equaling it to the volume sample. We're fetching values. We're creating values on those points if they're inside the volume or not. So the volume sample compares the position of the point, and then finds the same position in that volume and fetches the volume density attribute. Because why density? Because the second input says use the primitive 0. Here primitive 0 is the only primitive anyway, it's density. 1 means get the second input, and at p means like get the position, and then check. Even if it's equal to 0, remove the point. So if I go here, now it's doing a frustum culling only. So it's like just keeping the points that we see here. But now you notice there's a little gap here. That's because we need to create, first it's related to the resolution. If we go 30, it gets a little bit better, but you just want to give it a little buffer instead of going high res to match the complete edges. So that's like 25, 1.25. So this is on the right side. It's gonna go a bit bigger, as you guys can see. Okay, and we do the same thing, 0.25 here, 1.25 here. So it's like all directions. Now we have a little bit more points. So however, now what I need to do is that I need to, if I load my building here, I still have all my stuff. So before I transform things, I want to use the data, because this part is time independent, right? So I want to use this data and remove the points from the view, from the remove the mesh that has the same name of the remaining points before I do the transform. And I cannot do that in a static frame because the camera is traveling, so this needs an updated member, the updated members of its pieces. So let's drop down another wrangle. This time we're going to use another function called find prim val. So let's name this to remove pieces, okay? And I'm going to copy paste the code again. So what this code does is that if you do a find attribute val, if you click on the find attribute val and hit F1, it should open me here on my other screen and should eventually load it in. So this basically finds a primitive point vertex that has a certain attribute value, okay? So what does that mean? It means that I can get some points from here, compare that value of an attribute to see if it exists on this part. So now basically what I'm trying to say is, hey, find me the primitives that has the name attribute on this end of the spectrum. But I can actually do this before. Is this still packed? Yeah, so these are still packed. So I'm going to do this on the packed object. So it's going to be like point to point. So let's go here. So now what it did is it showed me some weird geometry, right? Because every geometry you see in this frame is actually inside the camera once they are transformed, and everything else in this frame is not inside the camera, so they've been removed. So how does this work? Find attribute value says we're feeding in this information. One means look to the first input. There could be second, third, whatever. Then look for point attributes named name and compare it to the name that, sorry, look for the name. So it's looking the name that is coming from here, because there's like a limited amount here, right? There's only 37,000. Then it compares to the name that is on the left side, and then it's going to return a point number if it's a match. If it's not a match, it returns a value named -1. Okay? And then I'm just saying if it's -1, remove those pieces. And then I remove those pieces. Then, because I want to be able to test this in both worlds, I'm going to duplicate this guy. I'm going to put a switch here. Can I do the switch? I can. Yeah, I'm going to use one transform piece. I'm going to say if I want to use, so the 0 will be the default one. So I need 2 switches in this case. Okay, sorry, let's do like this, then I will do the opposite one. Which one will be easier? This one is also, yeah, that's fine. So my 0, so this is in parts, let's call it, okay. So basically 0 means get all the pieces. I'm on manual, let's go auto. Let's save this scene. Okay, I'm gonna overwrite this because this was a bad cache. So we'll start from part 6. So I'm overwriting to part 6 at this level. Okay, so 0 means use all pieces, so basically ignore frustum, and 1 means get the frustum pieces. In this case, now I need another switch to do the same thing for the simulation point. So I'm going to grab my first, sorry, let's delete this, let's disconnect them. So my first input here in this switch will be, let's say, in sim points. Okay, and then my second one will be adjusted points. This goes here, let's say. 1 second. Now these are the points. This is the frustum pieces, points, all points. Yeah, okay, that's the deal. And finally, I'm going to poke this guy up here. So now if this is 0, this always has to be 0, otherwise it will explode. So then I'm going to go select input, copy parameter, select input, paste relative. Okay, so now if I look through here, at this moment I should see all the pieces transformed. If I switch this to 1, I should see only the frustum area. Okay, so obviously here's the catch. If you have a lot of reflective objects, this is going to cause some popping when objects disappear. But let's say it's very smoky, let's say this glass is dirty, we don't have the glass here, which we'll implement later. However, it's, I think, fair to say that it's going to be so much faster once we implement the it will be so much faster once we implement the let's say once we enable all the other buildings, pretty much. So, you know, use based on if you need reflections, if you have a lot of reflective objects or not. Now let's load the rest of the geo. Things should be faster now, obviously. That should be coming soon. All right. So now, look, if I look through the camera here, looks like it's all populated. If I zoom out, it's just a frustum. Okay, so that's one way to speed up things. Maybe, I don't know, maybe you need a turnaround on the presentation dailies for gray, you know, during your if this was your task. If you're doing a gray render, if you just want to see how the mood feels, you know, you don't need all that stuff. So this will this will definitely turn around much faster renders for you. So let's go now, and let's say out geo. Okay, eventually we will end up baking these into Redshift proxies because we are rendering in Redshift. So it may be worth that we just save what's in the frustum, or like I said, per building might be another good solution. All right, cool. So let's look through the camera. So this is only for viewing, of course, or rendering. We need the entire thing for doing proper sims. So let's do something like this now. Let's go on manual. I'm gonna turn off what I don't need actually. Here. Let's start the secondaries. Okay. Maybe let's, because this is a part of render node, let's make this bigger. Is it inside? Yes. Let's make another network box that is lined up with the environment network box that has all the other objects. Okay, let's call this building render. Okay, no shaders or anything yet, of course. Now we'll go here, not here, let's find here. Okay, this looks like there's quite a big space here. Let's make that smaller. And now let's start by building our Pyro simulation and debris simulation for our buildings. Okay, so I'm going to start this with the Pyro first. Let's give this object the name. Let's call this building Pyro sim. Building, oops, I'm not typing. Building Pyro sim. I mean, they're empty now, but I'm just going to duplicate it. I'm going to call it building debris sim. Copy paste, building glass sim. Bring it down here, building. Actually, let's name this dust. And let's name this debris. Okay, that makes a bit more sense. Now, I'm gonna dive into my simulations here, and I'm going to explain something. If I, because I already have this cached, I believe it won't show up now, but if I do that, just for the sake of all this is pre-cached in the previous lessons. if I select building 0, come here, this should return me a value of building 0 because the variable is generated. If I go here, I have my caches, right? So I'm just gonna cook all the way down here. Okay, it's gonna find the caches. I have my rest buildings as well. This means that I'm still calculating when it's a minus line, and it goes around, and it's just checking if the files exist, basically. Faster the drive, faster this will go. Okay, here it is also done. So now what I want to do is that you guys see here I have something here which I made a little mistake, which I want to explain. When you chain wedged objects, there's a few things we need to consider. It's like if we set up the frame range, I'll explain this with an empty scene. If we set up the frame range on top of a wedge that is coming without any node that says wait for all, then it's going to kind of like, I think, double the amount of the frames it will need to generate. So if like you see, which I think is best explained on an empty scene. I need to buy my new licenses. All right, let's go here. I don't need that. We can generate pseudo tasks. So let's go to tasks, topnet. Let's say I want to create a wedge of something that is 10 of them. Okay, I go and go to generate node. It's going to create me 10 boxes, right? Now let's say I want to cache this out. Geometry. Okay, this is usually what we're using. And if I say I want to generate this for 10 frames, so my simulation is 10 frames. So if you can, so this is like a dry run almost. You can do right click instead of cook. You can create generate node. So this created now 100 tasks, right? Because there's 10 wedges, frame range is 1 to 10. So that's 100 jobs. Now, if you, let's say this is a source, let's say this is like a cache sources task, right? So we need to run a sim after this, right here. So now because I copy pasted it, so my frame range is still 1 to 10, because by logic, I want to run a 10 frame simulation. But if I generate node, this is gonna create 1,000 jobs. So this is like so much more. So why is it so much more? Because now it's trying to creating a 10 frame job for each one of these boxes. So if you're chaining like this, you need to have like the first job defines the frame range, then you need to have this guy set to single frame. And if I do like generate node again, now it's creating this is like a QCing frames or something. So now it's creating 100 jobs, okay? The other way but the thing is now this job can start when this job is finished. If you have some sort of a farm that the scheduler, the tractor scheduler or the deadline scheduler is like, set up properly. But if you're running something like this at home, I generally don't want this to happen, because then I have to set the priorities. It's a bit more harder to control. So then what I do is that I say wait for all. And then I say wait for all, and this thing is still this many frames. And if I generate nodes, now it's going to wait. Basically, this job will never start before this is complete, which means this job needs to complete, so this can start, okay? You can do things like this as well. So you can say filter by range. Let's say you want to range it by 5. Okay, so then what's going to happen if you do a generate? One second, this is 10 of them. This is 10 of them. So then one of them is 100 frames, right? So you can do 100. Generate node. Keep items. So this is generating 100 jobs. Filter by range, 0 to 100. No, it's supposed to generate not this many. This is doing something funky. Let's try again. Generate node. This is creating 100 because there's 100 of them. And let's go here. This is supposed to group them actually. Filter by range. This is where I'm a little vague on this as well. Dirty. So I want to group these based on wedges because it's 10 frame each. So this is supposed to turn me 10 results. Maybe like this. Oh. No. Generate. No, give me the correct number. Filter by index. No, it's this. It's filtering by. Oh, okay. Now it's filtering by the index number. So this is giving me. This is giving me 11 because it's 0 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is okay. Let's investigate because I'm curious. This is. Index 1, wedge count 10. So where is this is 0? Wedge index 0. So this is 0, 1. So this should be 1. So it's overwriting itself. It's also 0. Okay. Now actually you can select these and it'll show you. So it's updating this one, this one, this one, this one, this one, this one. Oh, it's this just swapped to the next one. So maybe 100. It's not grouping them. Let's try again. I think it's grouping them. Oh, okay. It's here grouping them. Anyway, I'll stick to what we were doing. Probably need a bit deeper understanding of wedges, but for this tutorial purpose, this workflow will serve fine. So let's generate nodes again. So now all these dependency jobs are finished. So then this guy can start. So now I can explicitly say cook for this many frames, and it will cook for that many frames. So because, like I explained, we didn't put a wait for all, and then we also said cook this many frames, then it generated 10 frames job for each one of these jobs. That's why we end up with the number 1000. Let's close this. The fix for that is to put another wait for all here. So now it's going to say, oh, I'm confused. Obviously, we say cook the building, so it should ideally find those frames and not do the rest. So instead of 14 jobs, now we have 7 jobs, and this should fill up any second. Okay, now let's drop in a wait for all under this again before we start for our secondary simulations. Okay, now I'm gonna put another wedger because we want to be able to swap between buildings, right? I'm gonna name this buildings secondary sources. So before we start the sims, we need to create the secondaries, the sources. But instead of simulating all these buildings, I want to be able to test first with my building 1, all my chain, and when I'm ready I can just change this to 10 and then cache the rest. So let's press the plus button. This is going to be my attribute name, wedge building secondary sources, set to integer, and at this point I want this to be 1, okay? Because 1 wedge count, value will be 0. Basically it's gonna pick 0 because we can test that out. First value, right click, first click, so it generates, right click, work item info, it's gonna say building seed is 0. All these are all the captured attributes. Up above, and there should be one named wedge building secondary sources 0. Okay, so now we're going to test everything on our building 0. So now first we need to generate obviously the cached points. So let's drop in a raw geometry output. Let's hook this guy up. This is going to be named. So the names are very important because I use them for file paths, and they are linked to their they're linked to otherwise you need to, like, it's very easy to lose track of the file path. So I'm just using the same naming convention almost. This one was baked out. Oh, no, it's like this. So it's always same. It's the project folder geo underscore geo the name of the operator, and then the wedge, if it's a wedge, underscore wedge, the attribute that is inheriting, so it doesn't overwrite the frame names, and if it's a sim, $F. If it's not a sim, just same folder, wedge RBD.bgo. So in this case, this is not a sim, but it's an individual file. So this needs to be created properly. This is obvious. Let's color all our wedge nodes green. This is how I had them in my other scene, so they're a bit easier to follow up. Let's name them green. Okay, so they're green. All the geo nodes are black, so it's gonna be black as well. This is green as well. All right, I'm gonna duplicate this. That's gonna be my basically this. Before I start simulating anything, I need to bake a VDB of my buildings as well for speeding up the collision calculations. So just gonna paste this path. No, this is the name, my bad. The name goes here. I'm just copying pasting this because it's there, there's faster, but you can pause the video anytime to see. But again, like I said, these are always the same thing. The only thing that changes through these output files is this attribute, which is driven by this guy. All right, and then we're gonna do another wait for all, which means so by the time this is completed, but notice these are empty now, we're gonna fill these up. When this job is ready to go, it means that our simulations are ready to be picked up. So first thing I want to simulate is the Pyro, but I want to simulate the Pyro because I want to use the Pyro sim as an advection for the debris, for the dust particles. Okay, and this is actually like a pretty good workflow, even if you're generating anything. So you can start even without starting anything in the SOAP level. You can lay out your plan like this, and then you can start generating the SOAPs. And this way they're going to be like a bit easier to follow up. Like, you know, everything is empty, but you know that you need to create a building, you know that you need to fracture it, you know that you need to do this, you know that you need to do that, and basically everything can live in a top network because you can create here an object. Where is it? Because you can create an object network, and in this object network, this is the power of Houdini, right? You can say, I can create it here and say this guy has all my fraction work, so nothing even has to be even here. That's the entire beauty of Houdini. So let's go back inside, but let's not get sidetracked. Let's go all the way down. Let's maybe put these guys in a network box as well. Okay, because that's my RBD. This is my source generation for secondaries, and this part will be my sims. So obviously under every wedge, but my wedge settings will be as follows. Again, we are wedging the first guy only. This is my wedge name, wedge building secondary sim. So like this was secondary sources, this is secondary sim, integer again. I'm going to copy this, paste it here. There's one thing we need to remember, sorry. The wedge building debris source uses the debris source, which is actually a simulation. So we need to set the frame range, that is because we have a wait for all, right? So the frame range is 1000 to 1250. Same applies for this guy. But this one is not a simulation, so we don't need to say all frames in one batch, but debris source will be a simulation, so it needs to be all frames in one batch. I click on these as well. I don't know if these are related to if you send this to farms, but it's a sim nevertheless. Keep it on. So this guy's name will be not debris source 1, but rather wedge building Pyro sim, and its path will be using this value. Secondary sources, secondary sim. I believe so. Okay, wedge. Okay, let's write it here as well. So this is going to be this guy. It's going to be this guy. Okay. Now the result of this is going to be hooked up into another sim. So I want to wait for all this. Well, I mean, I don't need that, but I can chain things here if I want, but let's disconnect that now. Don't need it, we just need this to finish. And copy this guy again, hook it down. So this one is going to be named wedge building debris simulation. Debris or dust, you know, this is like. The name is going to change. The name of the attribute is going to change to a debris sim. It's still 1.1 because we're only testing the first part. I'm going to copy this. This is still a sim. It will go down here. Its name will be this. So basically this is very important because we will have to use this name to load back before we start simulating this guy. Let's copy its path so it's correct. Its wedge will be using this guy here. So this should do fine. It's a sim, obviously, and it has a frame range. Now let's start building. We are going to start building first the debris source. Obviously there's nothing here because we need to start building it in here. First one is the debris source. The debris source will be used for Pyro as well, so we can do the same thing. Let's drop in. So obviously we need to do first, we need to load the buildings. And remember our buildings were cached as a rest here, rest RBD buildings, right? So I'm going to copy this path, the object name. So let's do this one. Let's get the path fully. Paste it here, okay. Let's drop in a null. Let's call it wedge value. It's a bit more centralized. It's easier to control it from one location and then copy paste it because this attribute needs to be referenced several places. I find this a bit easier to follow up like this. Let's name this. We don't need to name this anything, but let's name it properly. Wedge value. Same again. So now this guy is going to be overriding this guy, okay? And it will inherit its value from our wedge node from TOPS network. So this will not now found anything because our $os means nothing at the moment. We didn't cache anything under file 1. However, we did under rest RBD buildings. So if I go here now back to my building Pyro Sim, rename my object, now it will find my first building in its rest state. Okay, remember this doesn't move, it's fine. We can set this to no geo. Actually, maybe don't set this to no geo because you do want this to fail if there is no building at that frame, at that location, but we do now. Okay, so the next thing is now I need to bring in the corresponding simulation points for this specific building, and that's going to be following the same workflow again. We need the name of the node because it's in the file path. Now since I follow the same naming conventions for my file path, I can copy this. Oops. Copy this, paste it in here. Come now. Okay, and again copy my wedge value and select this section exactly, right click, paste relative. So this should now load the simulation points. We're gonna do the same thing. We don't want to emit anything under, so I'm gonna put a clip. It's almost like a frustum culling, but you don't want frustum culling at this point. yet, or something really wide maybe, depending on the sims, because you do want smoke to be able to come from off camera and maybe go inside your scene. But we do want to remove the points. They are unrelated to our sims, which is inside, underground, so on and so forth. So then you can go remove. Oops, sorry, no, there's no remove. There's an attribute wrangle. You're gonna say anything that is not in this list, remove from here, and this is what we did before on our visualization loop for our sim. Find attribute val. Same logic will work here. It's gonna remove some parts that you may not see here at the state, but they are going to be underground. Okay. Let's actually see if this is, yeah, it's removing some pieces, which means that those pieces eventually fell off the grid. So here's a trick here for the debris source. You gotta unpack it. For this to work, you can run this through a regular shelf tool, like in a small test scene with the, I think there's a shelf tool for debris, but this is basically what it expects. But you want to unpack it before you transform it, because unpacking and transforming it is faster than transforming it and unpacking it per frame, because at this level here you only do it once. After here you do it every frame. Alright, so now I'm going to put this on manual because I'm going to put the rest of the nodes that require simulation, which is the debris source. So obviously I found the good numbers for this sim. You may have to do a few tests, and you remember you can do your tests like we did before when we did the simulation. You can blast a section here, you know, it's like something like this. You can put, you can say delete bounding box here, and because we are already removing it from here as well, so if you can just select a little, say even like this, I think you don't even need a bounding box, so you can just say points if you select, because this part is not changing topology. And if you do delete non-selected, and at this level here it should only have those pieces loaded and simulated. So it's like, obviously this is a lot faster to figure out the values. So but this has been already done by me, so you don't have to, but you still have to do it for yourself. Now it's gonna do the whole thing. Okay, so the debris source values I picked that works for me for this sim are that's 10 million for edge debris. These are fairly big buildings. Search rate is 0.1, search point is 2, lifespan is 4. Okay. Then I'm doing a little attribute cleanup, I think. Actually, at this point, probably not necessary, but let's do it anyway. There's no color, but there's, I believe, rest. I'm just going to copy it from my other scene. I don't need any of this, basically, but I need the velocities. Now let's go null, and let's name it out building the resource. Okay. Next thing is we do want to cache out the VDBs of these buildings. So I'm going to put a VDB from polygons. I'll hook this guy up here, but before I do that, I'm going to change this to 1. I'm going to change my distance VDB name to collision. I'm expecting velocity, so this point V, VDB name V, and it's set to displacement velocity, so it comes here. If I go like this and press auto update, this should now create some VDBs with some weird things, because V is not dedicated as a volume that is by default hidden primitive, but val is, I believe. Oh well, val is not as well, but we can keep it to V. Doesn't matter, because we can always rename these things and adjust it as we wish. But since it's a bit more confusing, I'm just going to drop in a primitive swap here, and this is also how you can make things visible or not visible in the viewport. And you can set the primitive. I'm going to say take the velocity and make that an invisible field. Okay. Now I'm gonna put a null here, and this is gonna go here, and I'm gonna say auto building collision VDB. Out building collision VDB, sorry. All right, cool. So now these guys are ready to be plugged in where we didn't touch. So this guy, I'm gonna pin it, go to my building Pyro source. So this is going to be my simulation source points from when things break. Now let's unpin this. I can just now copy, no, I'll do it one by one. Building collision VDB, frame range and all this set, that's fine, pin it. Go back to your simulation, no, not here. Here, this is my building collision VDB that will be baked up. So then what I want to do, obviously, is that I want to read this back per building, right? So I need to open a file node here. Since we are using node names for folders, we need to be able to read it back, so we need a matching path. So it's almost like exactly the same. It's actually exactly the same. Not this one, but it's exactly the same here. Oh, I broke something. I changed my file path. I need to undo. I was thinking I was changing my file path for this guy. Okay, let's don't touch that. Unpin this guy. All right, cool. So here, I need, this is the correct name. It is using the same naming command, so it should be fairly safe to put this guy here. But we're gonna change this time the wedge value, because up above we're I think we can use the same one even. Why not? Actually, we can use the same override to cache out and read back. Yeah, I'm gonna stick to that. We're gonna do a little adjustment here because we were using this, and I can use the same thing here. It's gonna be fine. We'll test it before per frame, but why not? So I need to be able to now load in my corresponding VDB as well. That will be cached out. So this is named the name of the tops node, obviously, and the same file path, because those will be created at those folders. Now what happens is, once I load this, I want to do a little processing, okay? And I try these, and it kind of make more sense for emission settings for a Pyro Solver. So let's go here and say I want to remove every point that has a length of less than 5. So you want to emit smoke, but not from really slow points, okay? Kind of like battle tested. Emission adjustment per point, and we're gonna test this out as well. We're gonna play with these to see what they do. So I'm here now, and let's drop in another wrangle. You also don't want to emit points from very lonely particles. Remove by density, and I'm going to explain this as well. So what this does is it checks the points neighbors within a given radius, which is 1.7, and if it's less than if len equals 1, it's going to remove the points. So if it doesn't have enough points, it's going to remove them, which means that if there's a very lonely particle, it will not be emitting volume, because it will not be in the system. Now I'm setting my defaults here. Default emitter values. It's just density equals 0.5, temperature equals 0.5. The other thing that I want to do is that I want to load this guy in, okay, and I want to feed some of this into the sim as well. So we can visualize this one because these are not generated yet. So let's go another attribute wrangle. I want to remove very slow parts from the sim. So I'll say remove slow parts. Okay, so if I visualize this, it removed all the slow parts. And I want to actually emit more points from these guys. 4 times. Again, these values are, not 15 times, 4 times. These values are to be tested. You can change this to your liking. So now I want to merge these 2 outputs. That's eventually will end up being my emission value. So what I noticed that is usually feeding the entire velocity to a debris simulation tends to create a lot of mushrooms. So this is kind of like a and I see this very often at work as well. If you're creating a smoke from a debris, almost remove all the velocities, because smoke from a debris is what's left behind. It's not a projectile, pretty much. Okay, like a fine dust version of this is not a projectile. So then it should have a little speed, but it's like it should be almost like it should lose its speed as soon as it leaves the main body. So that's why what we're doing here is this 0.1, not 0.1. So now we're ready to create a pyro source. So particle separation is set to 0.2. Okay, here, and I'm just setting it as keep input. Oh, actually, yeah, this should generate some, but actually it shouldn't, because I already have the next, but it creates the P scale and a few other attributes I think might come handy. Okay, next thing is always add noise, and this time I'm using attribute noise, pretty much standard, not blur, noise, pretty much standard tools for creating the noise that we see in the shelf tools. But I'm going to copy paste this one because I have some ramps. I'd like the ramps to follow. Okay, so it's like, create a multiplicative attribute noise on the density, temperature, and CD. And I just played with some values until I was satisfied with the breakup of it. So here the density is multiplied like this, but if you set it to, no, I'm going to put it back to what it was. I guess we can visualize what we are feeding in by saying show me the density, and we're what, 3. There's no density here, there's density here. Ramp from attribute, is this it's showing the CD, maybe remove everything else. So there's some breakup, it's not as much. There it is. Okay, so that's like kind of like the result of the values there. Now I'm going to add another attribute, randomize, just randomizing velocities. This time I didn't do them up there, so I realized I didn't do them up there, so I'm randomizing them. I'm setting their value. These ones are really, actually this is, I think, overriding this guy here because I'm setting it. It's set to Gaussian, so this should be like pointing towards every direction, which is a 3 float. And finally, Pyro source needs volumes, not points, so we go volume, rasterize, attributes. So if I check my settings, so I want to rasterize whatever I want to use in my sim, which is density, temperature, velocity. Okay. Here the voxel size is 1, particle scale is 20, and I want to create some motion blur from the attributes. So if I go look here now, this should give me some points, quite big ones. Let's turn normalize by clamped. Okay, so these are quite big in voxel size, so we may need to go smaller to get a bit tighter emission. But this is basically, with those values, there is 1 and 20, I really get very thick smoke. So that's why I'm bringing it down here. Maybe let's try 5. Okay, maybe this will do a bit better. And finally, this is actually now ready to be an emission. So this will be, let's name this out density, really. Now the other thing we need to do is load in the proper collisions, which is this one is here. So we're gonna merge these with the environment because it's just a building. So how do we do that? Let's drop in an object merge. Okay, I would like to go, I want to pin this. So that's for the environment, we need the environment. Let's go to terrain. Animated ground collision proxy. This can come here. In here, I want to create another VDB from this object because it's at the moment a geo. So VDB from polygons. Let's, oh, we plugged it in too quick. No, kill. The resolution is too small. Let's make this 2. Okay. I would be very upset if that actually crashed my scene. It wouldn't, but you know, it will be upsetting. All right, so we have volume here. We have another volume here, and we merge them. I'm not gonna load the center points. We can, but like it's up to you. Otherwise, you can load in the volumes, the sim here, but it would then this has to be cached, the center part. But since this we're mostly looking up, and smoke will probably not fall that much, but if it does, you need to bring in the center sim as well and pretty much do the same thing. And ideally, maybe even merge them. And no, this can be, this is always going to be static, not static, but baked as a whole here, so it's loaded back together with the center pieces, but this needs to be per building. Let's put a null. Let's say out colliders. So this will be named, I didn't name it, let's name it out collider. Now we put a Pyro Solver. This is the sparse one. Again, we're not using the .NET because why? No reason. We don't have to. And we don't need to use a master license, FX license as well. All right, so my resolution will be voxel size 1. Testing. I'm saying my, don't calculate anything below -70. It's closed. I'm feeding in STF and volume velocity as my colliders here. Okay, here collisions, because this one will require, I think, some conversion, but this one will not because we fed it already. And it's automatically set to deforming. This one would have to say what's coming in. You have to tell it or not. But we are feeding that in advance, which will give us some speed advance. All right, so in the solver, let me see if I did something in the solver. I don't have anything updated here as well. In the simulation, advection, reflection, I've changed to single project. I tend to find that to give a bit better results. Buoyancy scale is 0.5. Okay. So because this is heavy dust, we want this to go down. That's why we have a negative buoyancy. All right, in flames, I want this to emit smoke. Left the default values really. And shape is one of the most important. So this is again has to be tested based on your size and everything of your simulation and the buildings. Maybe for test reasons you're making smaller ones. So on my disturbance settings, I am setting my cutoff to 0.1. My pulse length is like how often your noise changes its speed. So my control settings, I'm using density, and my max is 2. And my turbulence settings, I'm using a swirl size of 50, like really big swirls. Grain is 6, and my level is 3. Okay, and that's pretty much it, I believe. My advanced settings are showing that I changed something. Resizing is set to just density. Okay. My sourcing is, I think, slightly adjusted. My temperature is set to 4, and target field is from temperature to what is it? Wait a second, because I don't have a flame field, so I'm feeding in temperature only, and for the last one I'm feeding the flame with the temperature field. So these are all same, I believe. Let me just double check. Density is scalar, of course. Density is an add by default. Temperature is scalar from temperature to temperature. Okay, so I made these separately. So instead of maximum, I create a pool, and its acceleration strength is 50. Okay, and deceleration is 0. So this, I think this started from one of these presets. That's why I was probably copying them and changing them accordingly. So let's check again. Scalar, density, that's fine. It's 1. Scalar, temperature. Its method is set to pool. Yes, that's good. The last one is temperature. The second last one is temperature to flame. This is add. It's 4, correct. And finally vector vval. So this is, I'm pulling in only 30% of it. Okay. Now the export. I am exporting everything but color. I mean, we're not generating color, so it shouldn't be a problem. Converting this to VDBs out of the box. Resembling velocity field by 2. Converting to, which means that it's like, instead of saying, because it's going to be a motion blur driver, and frankly for speed purposes, there's not really a fast velocity happening here. I don't even need to cache the velocity out, but I have to advect my particles, so I need the velocity field. But this will serve the purpose. Okay, so it's kind of like optimized as possible here. Oh, we are actually starting from 1000, not 1001. My bad. And then obviously this goes here and this goes there. Now it's gonna try to do its first frame, I guess, which should not output anything because we didn't cache any sources yet. And then this becomes your render. This becomes your let's call this not simple firefall. Apparently I was using it from simple fireball, but we'll call this BLDG Pyro Sim out. And now this we need to pull in. Let's put this manual. Let's go here, and this needs to be plugged in here. So pin this guy, go here, say I want to capture this. All right. Now the next thing is the debris, right? So this one is a bit more simpler because we did majority of the work here with all these parts. So what I need to pull in again is that I definitely need to bring in my building. So I'm actually gonna copy this part fully. But we're gonna use some of the information that we already pre-cached. So I'm going to do the same thing here. I'm gonna copy this guy, I'm gonna paste this here. Now let's go back inside the dust sim. Okay, so what I need to load in here though is my debris simulations, right? So maybe I should cache this so I can kind of show you the result and just go over it a bit easier. So let me pause it here. Okay, so I baked it all the way down to Wedge Building Debris Sim. I caught one mistake, which was once we updated the name from Sec Sims, we forgot to update it here, but once I corrected that, it went through just fine. So I have all the frames. Let's have a look what we did. So obviously we want to investigate how did the Pyro looked. So we can drop in a file swap just to read it back. And this is the Pyro sim. So if I look at it here, so something is happening, obviously. For 250 frames, I'll go to last frame. Let's put a visualization tool just so we can see it a bit better. Visualization here. Let's call it density. Density. It's a bit too dense, maybe. Okay, so things are falling down with the falling debris, and then they get pushed by the falling building, and this is where the speed picks up off the top of the building, which then becomes an emitter. And then also it gets pushed down with the sim itself, so it's preceding it, and then you get this nice streaming smoke on top. Obviously this is gonna look better with higher resolution. This is now quite high, I believe, low, I believe. It's it was, what was it, 1 meter voxel size. So each one of these is representing, each one of these edges you see is representing like one big, but because it's a big building, it's kind of like, okay, you know, it's working. All right, cool. So which means that this should be being read properly by here. So let's continue what we were doing here. Building debris sim. So I want to be able to read that sim back in, obviously. So this is my, what was I doing here? This is the building, right? We're gonna use, we don't even need to use this building, but let's bring it in, because I usually collide particles only with volumes unless I want bounce. But let's put it anyway, might come handy. Because it's gonna slow down our sim huge if we, because there's a lot of geo. If it was like a simple landscape, you know, it's fine, but like against a massive amount of geometry, particle sims can be slow, and we do want particle sims to be fast. Anyway, so let's drop in a file node. Let's load in our source points, which we cached out here, which we can also visualize. So this was our, oops, this was our source points. Okay, then we edit this falling part. Let's go back here now, back to our dust sim. Okay, so file here. So this is going to be named wedge building debris source. It's the name of our topnet again, but we are going to overwrite its wedge value. We need to get the path, which is using the same as this, guys. Anyway, naming conventions. So because of its name, it should actually load. Yes, it's fine. So I think this was clip, but I'm putting a clip again just to keep it, you know, little clean. -50. Don't give me anything from further than -50. Now these are going to be particle sims, so I'm going to drop in a wrangle node, and I'm going to say again remove fast. Oh, that's the wrong name. It's here, remove fast, and it's going to be saying if the length is bigger than 50. So it's just trying to avoid super fast particles like 50 units. Sometimes in simulations things explode, and then they make it a bit problematic to simulate if they're really fast. Attribute delete. So we don't really want super fast. Like imagine like a piece can get stuck in between pieces, and because that's the smallest fractured piece we tell it to become, it cannot break more. So it kind of, solver tries to push it out of the way, and then it may end up flying out with the speed of light, and you don't want that because this is not very accurate. Otherwise things would just break, right? So let's put a null. So we're going to go two ways with this one. One of them is going to be named out building debris dust. The other one is going to be named debris. Okay, let's maybe just go out building dust and debris. So now what I want to do is that I want to put a delete swap here. I want to get rid of 90% of those particles, okay, for the debris. delete by range should do. So I got like 10. Pick every 9 out of 10 and remove them. Okay. So this should give me a lot less points, but it should still give me points. So I need to say delete non-selected. Is this not working? 33,000, 37,000. Oh, sorry, delete selected. Something is stuck. I think I should be seeing a lot less. 37,000, 3,000. I think the viewport got. So I know maybe there's a template somewhere. No. I think the viewport got stuck, or it's loading something else. No, viewport got stuck. Let me save this as it is fine. 6. Okay, and I want to close this and make a new scene view. Okay, now it's kind of working. Let's go back here. Okay, now the next thing I want is to be able to read those building collisions that I baked out when I was using for the Pyro Sim, which are here, which is this. So basically I need to copy this part because I have the ground as well here in case some particles hit the ground, right? So let's bring this guy here, make sure that, you know, because we copy paste things, we need to make sure that, because we didn't, it loads in, you know, the the network, but because the dependency reader is named veg value, so it's still plugged in the proper way, so this should still work. Let's get that guy as well. Okay, so the collider is here. We may not use this one. I shouldn't have selected it because now it's going to load. Let me see, and we need to read in now the simulation, so we can create our advection layer as well. So let's pull this guy here. Let's name this same name as our tops object, and you know the path is exactly the same. Yet again, we want to replace this guy with the path of that integer attribute that lives here, which will be overwritten by this guy again. Okay, so did we do that over here? Oh, we didn't. It worked, but because it was set to 0, because we're only testing 0 now. Okay, we can do it though. Okay, this should return 0 regardless. And while we're at it, let's plug this one as well. So this is the Pyro Sim. They're using the same one. Anyway, that shouldn't change anything, but I'm gonna add this so I don't forget it next time. Okay. So this, we have the result. We're happy with it. Let's double check that it loads here too. It loads. Let's bring it on all. Let's say advection. Out advection. Now let's, okay, so these are our sources, maybe except this one, maybe unless we decide to use the geo. But this one, two, these are our emitters, these are advection object, these are our colliders. All right, let's drop in a pop network. Pop network. Let's go to first frame. Let's go to here. Now let's these are pop source, right? We don't want that. We don't want that too. We're gonna make this new. We want a pop source. Name it in dust. In dust we trust. Let's change its settings to points, and it's going to be using this guy, and its bird settings we need to play around as well. It's 500,000 points. life expectancy is 10, life variance is 20. That should give it enough amount. So then in dust we'll go in debris. In debris, right? Here I copy paste it, but I'm going to play with the numbers. So this is going to be like 5,000 because these are going to be instanced geos instead. Okay, so it's kind of like you want distance to live forever. So forever that's 5 seconds. So do a 400. I don't know. I think that's pretty much it. So what I'm doing is I'm just putting a color SOP here, so it's a bit easier to debug when I'm debugging them. So this is red. This is gray. Let's merge them. That's not SOP field merge. Let's just merge them. Okay, the next thing is I want to add a little pop force. So kind of like, they're a bit moving like as if there's some wind. Pop force. So my current values for this building is 4 by 30, but I want only stream dust to work. But for this to work, you need to plug it in, run a few frames, and then it's going to populate the group. So I want the wind to only work on dust, right? Because the debris is too heavy, it will fall. Ignore mass. I have a pop property here. Pop property. So the pop property will create random mass values and friction values, okay? And turn this guy on. So there's a preset here. It says randomize mass, right? And what I'm going to do is that I'm not going to randomize the mass, but I'm going to randomize the P scale, and I'll tell you why. And I'm going to randomize the friction. So I'm going to copy paste this. I'm going to save friction. Okay, and next thing is the pop speed limit. So the pop speed limit maximum speed is 20. So you really don't. So we want to add spin, but we don't want them to be spinning like crazy fast. Okay. Let me see. Did I feed any custom attributes before I feed this in? No, I think that's it. Let's go back in to my popnet. Okay, so we need to advect these, pop advect by volumes. This guy comes in here, and I want only dust again to be advected. I'm saying SOP data, pin it, bring it in here. It's this one. It's set to well, and its velocity scale is 0.5. Okay, and that's pretty much it, I think, in terms of these settings. Now let's bring in our collisions. So let's drop in a merge. Actually, I think we don't need that because I don't use this one. No, let's keep it in case we change our minds. Oh, because I was creating some spinning values based on some tutorial I found, but then I kind of end up not using it. That's why I think it's here, but you know what, let's disable it. Okay, so we need one static object basically, because we merged the volumes. So static object collision, because there we are only feeding in volumes, right? So this goes left, says left inputs affect right input, so this is left to right. All good. And let's pin it here. So the bounce will not be calculated, or friction, I believe, because SOP path is empty. So SOP path is empty because the feeding in geometry will result in a better sim, but it makes it so much more slower. So I'm only interested in colliding the volume field, okay? Which means that I can use collisions RBD solver volume mode, change the volume sample by size. I set to 1, which is not connected. I think it reads in anyway, and then proxy is fed in to proxy volume, and obviously I need deforming geometry to turn on. Let me save. To make sure that this is working, all you need to do is initialize first frame and turn this guy on. And if it wait, so there's something. There's already a problem. I think this doesn't look correct. I was expecting to see the whole building. Let's press play. Yeah, we're not seeing the building, so something is off. Maybe here. This is loaded. That's fine. Let's just try feeding in this guy. So I was expecting to see this both working. Let's dive in. Let's put the flag here. Okay, out collider. Let's just bring in the building, see what's going on. Maybe it doesn't do merge. Okay, I think it doesn't do merge, so this is something I don't know, but we can fix this easily because we need the ground as well. So let's say out BLDG call VDB. This should be the ground. Let's give it another. Now here out BLDG, not BLDG, terrain call VDB, terrain collision VDB. Okay, you go down here, you go down here. We just have to duplicate it and then put another one for the ground. So this is terrain. Terrain. Pinned. Come here. Go there. This one is terrain. I'm just going to copy the name because we changed it. There are a lot of moving parts, so we have to be really careful when we change things. If they don't update properly, they will not simulate as we expect them to. Okay. So this is building. I turn on the visualization. Collision guide is turned on. I should see a building. Good. I turn on the terrain. Collision guide is on. I should see the terrain. Good. Make sure you turn these guys off. They're really slow. They don't need to be there. Now, the only thing I need to do is bring this guy in here. So this should now work. We can say this should be no change. And it's a collide relationship. So this should now work fine. Okay. Okay, I don't want any bounce. There's no bounce, but still. This is turned off, this is turned off. So let me turn this off first. Press play to see what it does after I save. So I should be seeing particles falling down. Not because we don't have gravity. Let's put a gravity. So the red particles must be falling down so much faster than the rest because they're heavier. And I think this is what we are seeing here as well. Because they are not advected. Right now there's no collision, don't forget. Let's make these bigger points to see if the red ones are falling faster. Yeah, so they're debris because they're falling much faster, and then the white ones are dust. They're not falling as fast, which makes sense. And the next thing we need to do is to see if this is working by turning these guys on. Then pressing play again. Things should obviously slow down due to collision, and things should not fall as fast because now they have floors, but things will kind of slide and act accordingly. All right, now we just need to sim this as well. Oh, not sorry, not so fast, Tim. We did not set up this important part, which is actually pretty cool. So something will come out from here, but now it's fetching everything. At that level, it will fetch, because it has an asterisk, it will fetch everything, okay? We are only interested in fetching the dust or debris. So I rename this to dust. and now I'm saying here, just give me dust, okay? And I'm going to put an attribute delete, and I'm going to say only get me ID, velocity. That's pretty much it. I have the groups, so I know what is a particle and what is the debris and what's the dust. So now here's the trick. And I don't think I have one here to show you the difference, but once the caching is finished, I'll come back and show it. I would like you to drop down a convert VDB points node here. Let's see if we can cache out a few frames. It makes much more difference once this is cached if it has a lot more points. But let's cache it at this level now. So we're going to optimize our caches by reducing their size. So a lot of hard disk space saving here. So we can convert our points to VDBs, okay? So my current settings for the sim has been 16-bit. Position compression, we want 8-bit fixed point. So obviously lesser it is, higher the compression, lesser the representation, right? But we are talking about billions of points that are extremely hard to notice if they shift 2 digits after 6 digits of 0 to the right or to the left, or if the color is slightly off, so on and so forth. So I really don't need that information. So what happens is, I can show you the result. So right now they're VDBs. Okay, let's put it up in a null. Let's see even if this level is going to make a difference or not. So I call this out building dust. Okay, so here it's a particle. So I can say save geo, and I'm gonna do this test here. I'm gonna say this is out. I can do this here. Doesn't matter. I have a temp folder too. Temp is too busy. Let me do it on this stuff. There's nothing private there. Untitled BGO, I'll call it BGO PTC, GeoPTC. Let's call it GeoPTC. Save. Now let's do the same thing from here. Okay. Now this is a VDB, but they are points. Okay. So let's call this VDB point cloud. Save. Now let me have a look at those file sizes. Did I overwrite the other one? I don't see it on my desktop. Let me try again. Okay. So let's have a look here. GeoPTC is 10.6 megabytes. VDBPTC is 6.1 megabytes. So this actually gets even more with a lot more particles. So you can almost half the size of your storage needs for your simulation. The caveat is that only some studios support rendering VDB points, but at home you usually do a live render, so we just have to unpack it before we render it, okay, or convert it to proxy, Redshift proxy before we render it. But at this point we don't need to, so this should be just fine. So this is good. Let's save it and run this as well, and we'll watch the results right after. Pause it. Okay, so that's finished, and this is the current result of our dust sim, and we were investigating our particle sim, the volume sim as well. I mean, I guess it's a bit better to cache this out with a bit higher resolution. Volume visualization. Right here we did this guy here. Density. I brought this down. Do I have lights on or something? Yeah. Okay. Less density, or increase the maximum, probably makes more sense, and maybe not black based on the color, but something like this. Okay, so now this one concludes the secondaries for Pyro and Dust Sim. So next lesson we'll look at the glass and the debris in the next video, and I think after that we are good to render. I think there's a few things I didn't touch. I guess I skipped the trees. No, I did the trees. Anyway, I'll do an overall check. We'll do a little bit test renders on this simulation scene we have, and then we'll start building our render scene. So thank you for watching.